Здравствуйте. Следующую лекцию проведет Дэвид из BoosterMedia. Лекция у нас называется «Избавляемся от узких мест в производительности мобильных игр на HTML5». David, you can start.
Okay, great. Hi. Okay, so today I'm going to present to you some tricks that we use to overcome serious performance issues in HTML5. But first, let me introduce us, BoosterMedia. Myself and Natalia in the front row over there. We're here from BoosterMedia in Amsterdam, the Netherlands. Basically what we are is we're an HTML5 games company. We operate a huge pile of HTML5 portals. We have over 100 platforms and several hundred games. And we're constantly looking for more HTML5 games. So if you have games, there'll be a slide at the end with contact details also of Natalia, and you can get in contact with her. But you can see pretty much what we do. We've won some awards. We're, I think, the leading mobile HTML5 games company in the world. We offer platform solutions for many different partners, and you can always come to us for anything basically HTML5 related. Yeah, as you can see, we have mobile, tablets. We also are now moving into PC. So we kind of joke internally that PC is our second screen, and we're moving away from mobile toward PC. Myself, I have been in the games industry for about 6 years now. I've worked on a lot of different titles. I used to work as an indie game developer. And then during the course of last year, I moved across to BoosterMedia as an HTML5 game developer. We, within BoosterMedia, have our own game studio, and I'm the lead developer in the game studio. Okay, so what's the issue with HTML5 performance? Especially with canvas drawing, HTML5 performance is all over the place. In a lot of devices, it runs quite well. But in some devices, especially where you don't expect it, it doesn't run very well. So I wrote a little benchmark just using canvas draw calls, no custom engines or anything, and just ran it on these devices. And you can see what was very, very simple, just 100 of the same image drawing. On some devices, especially Samsung devices, it was really struggling just to draw 100 images. And there's maybe something interesting to note there, and this is what I kind of put some question marks next to. The Galaxy S4 running Chrome, which should be pretty much a top-end device, performs worse than the Galaxy S3 running Chrome. And there's no good reason for this. It's basically the same software running on it, but for some reason it just runs worse. So there's a lot of things that we can do to overcome it. WebGL is often said that this is going to fix a lot of the problems. But the issue with WebGL is that on a lot of the devices that it runs on, they run Canvas just fine. So WebGL doesn't really help you solve a problem, because on the older, slower devices, there's no support for WebGL. So let's go through the devices in general. iOS is pretty good for the most part. Because there's basically one browser and one set of devices, stuff works pretty consistently. Full screen draw calls are very slow. So if you have like a background texture, that is normally quite a bottleneck, especially on iPads. On old iPads, that is a serious problem. The web view, so if you're wrapping your app to put it on the App Store, that rendering is much slower than in the Safari browser. In iOS, I think it was 6, they introduced some performance increases for the browser. The JavaScript calls suffer from the same thing. On the web view, they are much slower than in Safari. And all browsers other than Safari use the web view because Apple basically prevent developers from writing their own custom browser. So Safari is always your best bet on iOS, and that's what you should probably be benchmarking against because it is the vast majority of your users. Android is a complicated browser. A lot of people say that it's a lot like IE6. I don't know if any of you remember those days, but not a lot of fun was had. So it's got good standard support generally. It works pretty well. A lot of new features are supported. But because each manufacturer does something different, Sometimes something works on the Galaxy S3 but doesn't work on the LG G2, for example. And so they've all got something a little bit different, and they all have their own bugs. So luckily, some manufacturers now, like Sony, are moving toward Chrome as your stock browser. And that's solving a lot of problems. But Samsung and LG, for example, still give you a stock browser which is slightly customized and has some issues. Just a note, a game that I'm still working on, actually, but we've published already on our own portal, Games Plaza, is Bubble Fever. And we've noticed on the Galaxy S2 sometimes better frame rates than on the S4. So even within the same manufacturer, sometimes the software, it's totally different between devices. Android 4.4 is quite an interesting one because in theory, they've replaced the web view with Chromium. So it should run better. But they seem to have forgotten to implement hardware acceleration on the canvas. So that means that anything running in a web view on Android 4.4 that's using Canvas is normally much slower than most games running in the stock browser on a Galaxy S2. Which is quite sad because we're talking about extremely high power quad-core phones and you're getting 4 FPS because there's just no hardware acceleration. The good news is that, and I only saw this week so it didn't make it into the presentation, but the Android 4.4.3 changelog was leaked. And they've integrated all of the Chromium improvements, including hardware acceleration. And because it's a minor version, it should help and should go out pretty quickly to most devices, I hope. Windows Phone, as I said, deserves an honorable mention. We were really surprised. We didn't expect stuff to work. We didn't target for Windows Phone. And we decided to fire it up on an old Lumia 520, which was just a personal test device that I bought. And it worked very well. We had no issues. The performance was pretty decent considering a Lumia 520 is a very low-end device. There were occasional standards issues, which Internet Explorer tends to, if it hits an error, instead of continuing executing code, it tends to stop and crash the game. So if there's some standards issues, you need to fix them. But we had similar issues in Firefox, so to fix them was a couple minutes work, and we were up and running on Windows Phone, which was excellent. Another big advantage is if you're developing on Windows, Internet Explorer on the mobile behaves exactly like it does on the PC, which is fantastic and helps development quite a bit. Okay, so there's some quick cheats which sometimes work. They don't always work, and sometimes they work on one platform and not the others. But they generally are good things to always have. So one thing, and a lot of developers do this, and we try and do it as little as possible, but it still has to be done, is upscaling your game. For normal mobile, we run it in about 50 to 70% scale, and then upscale it for the correct screen resolution. You should also cut down on the canvas translate, save, and restore calls. If some engines tend to call them even when they're not needed, so even when there's no scaling, no moving, they still call these functions, and that adds to overhead very, very gradually. And if you've got hundreds of objects on your screen, every call counts. There's a quick trick there to set the context width to context width. Or I think it should actually be canvas width to canvas width. But it's a quick trick to clear the canvas. But if you use it, you've got to be careful. You've got to exclude the Galaxy S3 from that. It's a bit of a weird one, but we found on the Galaxy S3 web view, it eventually crashes if you do that. So it's a known bug in the Galaxy S3 web view. But generally, we found on most devices that saves 1 or 2 FPS, which is quite handy, actually. On iOS devices, I've inserted a little chunk of code there, but you should always insert 3D transforms into your CSS for the body. It seems like on old iOS devices, they don't pick up hardware acceleration until you trick iOS into thinking the element should render in 3D. And then it will insert it will add hardware acceleration, and it will give you much better performance on some devices. It's not on all of them. I think it was iOS 6 on older devices. Obviously, use sprite sheets because texture swapping is always expensive. Be smart with your textures. Less draw calls is faster. So you see, I've got that it looks very funny, but initially that was 3 textures. And what we did was we kind of crammed it into a single texture, so we do a single draw call. And we did that with, I think, about 20 or 30 textures, and we cut them down to about 3 or 4 draw calls. And the end result was a massive increase in performance. We also discovered that depending on the engine you're using, drawing text is very, very slow. This kind of makes sense because normally text, each character is rendered as a set of 4 vertices. Or depending in Canvas, it will be probably internally something along those lines, and then stroking each character. So what we do is we kind of push our text updates over several frames. So we don't update any dynamic text on the same frame as each other, and then we offset it a little bit so that there's no big spike in performance. Also, don't draw if you don't have to. I mean, it seems obvious, but if there's sometimes like a big background that doesn't change, try and separate it out. If you don't have to draw, you shouldn't be drawing. So, as I mentioned, full screen draw calls are very slow, especially on iOS. So what we did in Bubble Fever was we were using Phaser engine. We were using the old version of the Phaser engine. I'm not sure if you guys know Phaser. We were using 1.1.6, I think, in the final build. But they don't really support layers. So what we did was we set the canvas to transparent, and then we added our own manual canvas layer behind the game. And then in our actual game loop, when you got into the game screen, we quickly draw the background onto the game screen. We basically took the exact same code from Phaser internals, drew the background, and then just left it there. And that saved, I think, about 5 to 10 FPS on some iOS devices. It was a huge improvement. Lag spikes are another common issue with HTML5 games, mostly because of garbage collection and, of course, allocation. So there's a trick which you can use to get around lag spikes. If you generate something called a pool, you can kind of insert a whole bunch of pre-created objects into the pool. So maybe when the game view is actually loading, an example would be we have these animations which show when bubbles are popped. We create 15 to 20 of them initially when the game's loading, and we just leave them aside. We don't draw them, we don't add them to the actual visual game, but they're there. Then when we need them at the end of or when you're popping bubbles, we grab however many we need out of the pool, so they already exist. We reset them to their default state, we draw them, and then when they're finished, we put them straight back in the pool. So this means we have no garbage collection because we have no allocations. We don't create any new objects, we don't destroy any objects. And we've basically gone through all of the game with profiling to find the points that need this, and we've created pools of those objects. So we've got things like text in pools, all the animations, what Phaser calls tweens, we've put them in pools, we've put sprite effects, all sorts of stuff. And yeah, the final big thing, and this is what I'm kind of rushing through to get to, is profiling, because I want to actually show some basics of profiling in Chrome. Chrome gives you a built-in profiler. It works on desktop and on mobile. You can see exactly what calls take how much time, what's slowing your game down, and you can analyze it until you get to the point where you can find out exactly what you need to cut down on. I mean, if you're trying to run at 30 frames per second, then each frame needs to be 33 milliseconds or less. So if on mobile you're taking, one call is maybe taking 10 milliseconds, you need to cut that down as much as possible. The Chrome profiler also includes a thing to see what's drawing and how it's drawing, which is kind of cool to know if you're actually drawing stuff that's off screen. The older versions of Phaser didn't include automatic culling of objects off screen. So we discovered that our bubbles levels were kind of going a couple hundred, maybe 400 or 500 bubbles off the screen, and they were all being drawn, which is obviously very, very bad for performance because, yeah, a couple hundred extra bubbles being drawn off screen. So it's good to see actually visually that happening and know, oh, we've got a problem here, let's do something about it. Okay, so let's get to Chrome and let me show you how we can do this. So I hope that's clear. in the Chrome developer tools, you can see we're running in Phaser. It's got its own local host setup. This also, by the way, works on mobile, so there's no issue with that. But the Chrome developer tools give you the JavaScript CPU profiling and capture canvas frame profiling. The capture canvas frame is exactly what I was talking about, that it will show you what's actually being drawn on any moment. So if I take a snapshot here, you'll see it actually shows me we have in total 20 calls happening to the graphics card of this device. And then it shows you, as the frame gets built up, just one by one, every little bit at a time. You can see we have dynamic text. We don't do it on images, so our text draw calls are quite expensive. Okay, so what I've done for this presentation is I've got a couple hacks, which basically these are things that we discovered, and we discovered it in Phaser, that the older versions of Phaser, they're all fixed now in Phaser 2, thankfully, but the older versions of Phaser, there were a few things which weren't quite optimal. So every time we profiled the game, we kept seeing some stuff pop up from the engine side. Thankfully, the developer noted these as well and has gone a very long way to fixing them. But we were still using the old version of Phaser, and we didn't want to upgrade yet, and it's a good thing because we had a couple issues with upgrading. But when we did see this, we had to find a way to work around it because we wanted to increase our performance. And as you can see on PC, we're running at a solid 60 FPS. There's no problem. But if I do some profiling, and this is with all of my hacks off, you can see when I zoom in, especially when I throw a bubble. So let me profile and throw a bubble. Okay. You can see there's basically no gaps between the frames here. So we're pretty much running as close to the limit as possible. But we've got a big difference here. We've got all the rendering. This makes sense because there's a lot to draw. But we've also got the Phaser updating happening here. And the pre-update happens quite a bit. And I think we'll also see a post-update just now. So these things seem to be occupying quite a bit of time, and the rendering seems to be occupying a bit of time. So I might say, well, what's wrong with the rendering? Why is it taking so long to draw this game? So maybe I capture it, and I see there's 845 calls. So if I go to the top, you can see the game being constructed image by image. So we've got the platform, the dog. And then I don't see anything happening here. And it took me a while to work out actually what was going wrong. But if I go up to, I think it's somewhere around here, you can see the bubbles are actually being drawn even when they're off the screen. So this was one of the hacks that we noticed. So if I enable that, there's an auto cull setting, and we also set the bubbles to invisible if they're above a certain height. And I load it up again. Let me go back to that level. Okay. Take a snapshot. We've gone from 845 calls to 343 calls. So you can already see, and I'll show you if we profile it now for a second. Suddenly there's gaps. Where that was a solid line, this is now very, very sparse, gap-filled selection of draw calls. And now it's just drawing. So that little hack also included another fix, which returned early. So if a bubble's not moving, we no longer do any of the updates to it, like updating its position, updating its location, rotation, anything. And within the engine, we don't do any of those things either. So that was part of what that hack does, so preventing more and more calls. But then when I throw it, of course, stuff is still happening. So maybe I throw it, and then you suddenly see some big chunks. Now you've got like the pre-updates are taking maybe just as long as the drawing. So you can see all of these are taking quite a bit. So I won't go into too much detail on what these hacks do, because they basically just, I mean, they're hacks to return early or to get out of drawing or updating something that doesn't need to be updated. But if I refresh it, you'll see that we basically cut down the pre-update to only the bubble that's moving, because, yeah, that's pretty much all we want. Another thing Phaser was doing internally was that every image had a physics body attached to it, which he also fixed in Phaser 2.0 by adding a new class just for drawing images and then one for drawing dynamic world objects. We also noticed this early, so we discovered a trick to, and I think we've got it over here, where it's hack number 4, where we set the body of the object to null, and then we discovered internally Phaser doesn't do any physics on the objects. So all of our menus suddenly doubled in frame rates. In-game, anything that wasn't dynamic suddenly doubled in frame rate. We also removed the bodies from all the bubbles that you see in the grid over here, because they don't need to move until they fall. And if they're falling, well, then we just we add a body to them when they're about to fall, and then they fall. So we kind of do tricks like that. But I think if that's loaded, let me do some profiling again. So now suddenly, for the most part, those extra calls to the pre-update, except if something's moving, they're just gone. So now our bottleneck is basically drawing. And this is something we kind of noticed only afterwards, but drawing performance in HTML5 is still, it's quite tough on some devices. So in hindsight, making a game with this many bubbles on screen was quite a challenge because, yeah, there's a lot of stuff to draw. But the fact that we could get it running, and it runs, I think, pretty well. I mean, if you take it in Chrome on a Galaxy S2, we're still getting about 30 FPS. So we've managed to squeeze a lot out of it. And if you take it in the stock browser on the S2, I think we're about 15 FPS, but it varies. But so we've managed to get it down to basically that. And I see I only have 3 minutes left. But I think you get the idea of how you can slowly go through this. You can look at exactly what's going on over there. You can see what calls are being called, how long they take. Chrome also shows you the total time for each call. It shows you there, for example, 5.3 milliseconds. So I know that's well within our frame limit. So we know what to cut down on and what to optimize. And then you can just aggressively analyze it and see if there's any calls you don't need to be making. But I wanted the Q&A to be a little bit longer because, yeah, if it's a presentation, then I want some questions for any demo stuff.
Thank you, David. Если у кого-то есть вопросы, поднимайте руки.
David, thanks a lot for excellent presentation. I do have a couple of questions on, because actually I'm giving a chat on the similar topic tomorrow, and great. Some of the things, they are not quite much my measures to my surprise. First thing, in one of the tests, in the first one I think, you've said about number of images you was able to render. Yeah. Was it from the big sprite sheets or from a small image?
I only had one image.
And so this was really a small image?
Yes.
This was.
Yes.
Let me share one observation there. In Chrome, there is an issue of hardware versus software canvases.
Yeah.
And small canvases becomes software canvases, and rendering that might be a possible explanation of what happened.
Yeah.
So yeah, that would be good to know. And other thing, can you clarify on which devices you tested this hack with the several layers on iOS?
I think the iPad 1 was really notable because full screen draw calls, and I noticed this before in the previous work I've done. On the iPad 1, a full screen draw call it kills the device basically.
Right. Thanks for clarifying that, because one thing which we have there, which affects us on new devices, is that if you do not have this approach, if you do not have multiple layers, you can skip entire clear canvas. And I found, actually in my test, I found that on your Chrome's device and on your iOS devices, it actually makes things worse if you have several canvases.
Yeah, yeah, that's true. It's a very good point. With the engine we were using, we we couldn't really override the clear. I mean, we could have
Right.
if we wanted to hack the engine a bit more.
Oh, right.
So we stuck to what the engine kind of gave us. But yeah, it's a very good point.
Okay.
Not clearing is better than clearing. And that's also why I mentioned the was with hack, because it's a lot quicker than a normal clear. So if you do need to clear, it's really useful to do that.
Right. And actually, last one point is not really a question, but let me just share one observation. I also thought all the time that rendering a text is a very slow operation. When I actually tested that on iOS 7.0 and recent Chrome, it turns out it is not.
Yeah.
I could render 200 text messages maintaining 60 FPS right now.
Yeah.
And what adds to that is actually engines adding a lot of overheads to support multi-line, etc. That's
Yeah,
a huge
exactly.
surprise.
Exactly. I mean, if you ever do a text processing algorithm with the multi-line, it's always a lot of work and a lot of extra cases and stuff. So
Thanks a lot. It's really interesting statistics out there.
Thanks.
Еще у кого-то есть вопросы? Нет? Well, thank you, David. We don't have questions anymore.
No, thanks. And again, you know, we're a games network and publisher as well as having our own game studios. So if you have HTML5 games and you're looking for partnerships or publishing your games on our network, Natalia and I will be at the booth today and tomorrow. We're in the silver room. And you can contact Natalia at the license at boostermedia.com. Otherwise, if you have any technical questions, feel free to email me. And yeah, you can download the presentation if you want. Thanks.